In this video, we'll see how to solve equations and inequalities and really focus on what's happening and how to show the work. So in general, here are the goals, right? We want to find the value of the variable by getting it alone on one side of the equation. That's called isolating the variable. To do that, we'll do a few things. We'll simplify each side of the equation. Sometimes we may need to use the distributive property and combine like terms. We'll get the variable term alone on one side by zeroing out the constant. And then we'll isolate the variable, and that means we're going to get that coefficient to be equal to 1 by dividing by the coefficient or multiplying by its reciprocal. And finally, we can always check our work by substituting our answer back into the original equation. So let's just see what a model of this is. We've modeled before x minus 5. So on the left side of the screen, we have x minus 5, and now that's equal to negative 3. Well, how do I get x by itself? What I need to do is I need to take off 5 of those negatives. But I can't do that on the right side to keep everything balanced, which is so important. What I do to one side of the equal sign, I must do to the other. Really, what I have to do is I have to add 2 more of these red squares so that I could take away 5 of them. But then I've changed the value of what is over there on the right side. So to make the value of the pile on the right side still equal to negative 3, I've got to add 2 positive tiles. The overall value of this pile is still negative 3. And so now I can take away 5 of these red tiles on the left side. But if I do that to the left, I have to do the same thing to the right. So what do I find out? X is equal to positive 2. Okay, let's see how we can do that now with an actual equation and not the model. I've got m minus negative 13 equals 25. First thing I really want to do is simplify this. I'm going to rewrite this as m plus 13 equals 25. Now, how do I get m by itself? Well, I see that I'm adding 13 to m, so I want to do the opposite of that. I'm going to subtract 13. But if I subtract 13 on the left side of that equal sign, I have to subtract 13 on the right. This is how you have to show your work. You're going to be graded on showing that you understand how to balance an equation. 25 minus 13, that is 12. And I can always check my work. I can take that 12 that I got as my answer and substitute it back into the original problem. 12 minus negative 13, that's equal to 25. It equals what we said it should be. All right, now let's look at this inequality. I've got negative 13 is greater than or equal to y plus negative 4. I'm going to make this a little bit easier to look at. I'm just going to rewrite it as y minus 4. And now, how do I get y by itself? Well, right now I'm subtracting 4 from y. To zero out that constant, I'm going to add 4 because it's negative 4 plus 4 gives me 0. But if I add 4 to the right, then I better add 4 to the left. Negative 13 plus 4, that is equal to negative 9. So I get negative 9 is greater than or equal to y. Now, I am not done yet. This is an inequality and not an equation. I need to also graph this answer. So just like we've been practicing, I'm going to mark the boundary, negative 9. I know I'm going to need a filled in circle because I've got the greater than or equal to sign there. Now, negative 9 is greater than or equal to y. So what numbers is negative 9 greater than or equal to? Negative 9 is greater than or equal to all these numbers to the left. And that is where I'm going to put my line there to graph the inequality. And then really important, I want to check this work. So I'm going to choose something that's over here in my blue line area. And I'm just going to choose negative 11, but you could choose negative 10, you could choose negative 12.2. I mean, you really can choose any number that's to the left of negative 9. So what happens if I choose negative 11 and I add negative 4 to it? I want to get something there so that this relationship stays the same. Negative 13 should be bigger than or equal to that, right? Because that's the original inequality. And I want to substitute a value in to check to see if it works. So negative 13 is bigger than or equal to negative 11 plus negative 4, that's negative 15. Is this true? Yes, it's true. So I have solved and graphed this correctly. Let's just see what would happen if I did it the wrong way. Let's say I graphed over to the right of negative 9. And let's just choose 0 here. If I tried to substitute 0 for y, so 0 plus negative 4 is negative 4. Is negative 13 greater than or equal to negative 4? No, that's false. So what is this saying? It's saying, yeah, I could choose any of the numbers that I've graphed over here. And if I substitute them for y in the inequality, I'll get a true statement. And that's how we solve equations and inequalities by addition and subtraction.